me show you really quickly how to bake bread. If you've never baked bread before, it's actually fairly straightforward. We only have a few ingredients. We're going to be using yeast, a little bit of sugar, and that will help get our yeast going today, flour, and water. So bread primarily is made from wheat, but we could use other grass plants as well. In lab, you are going to pick a grass plant, and you are going to use the flour that's been made from that grass plant. Today, I'm going to be using some all-purpose flour. This is from a company in Wisconsin called Meadowlarks, and what they're doing is they are growing their own grain and then milling their own grain. So I really wanted to be able to support them in bringing us local grain products because there aren't a lot of companies that do that. And I really wanted to try their all-purpose bolted flour. And what this means is that they allowed the seed to start to germinate a little bit before they turned it into the flour product. So that may lead to kind of an interesting type of bread. It may be a little bit different than the all-purpose flour that you buy in the grocery stores, especially if that flour has been bleached and a lot of those nutrients removed and then taken that extra step and enriched. So note that every grass plant's flour does behave a little bit. It might create a slightly different bread with a different texture, a different flavor, and that can be pretty fun to experiment with if you get good with this. So in your lab manual, we have the recipe. In this bowl, I have already measured out some yeast, and I am using the active dry yeast, not the fast quick start yeast. I'm just using the regular yeast. So in this dish, I have measured out my yeast and I've measured out my sugar. My next step is I need to add hot water. I want to get the hot water super, super hot. Now, most of our tap water in our homes is going to come out between 90 to 100 degrees. So I'm going to get my tap water super, 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 super hot. If it's above 110, it's closer to 120 degrees, we could kill our yeast, but very few of us have our hot water heaters set to that level. You may want to put a thermometer in the hot water stream as it's coming out of your tap to see exactly what temperature it's at. Once you get above 90 degrees Fahrenheit, we know we'll be able to wake up our yeast. So I'm going to add some really, really, really hot tap water. I've got the sugar available, so once my yeast wake up, they can immediately start eating the sugar. And the next thing I will be showing you is what my yeast look like once they have woken up, and the signs that I'm looking for to let me know that my yeast are awake and they're ready to start working. They may not necessarily want to work to make bread, but that's okay. So I've mixed my yeast, sugar, and water together. I have a really consistent slurry right now, and when we look at it, we're not going to see much action. It just looks a little bit like a sludge. That's perfect. I'm going to set this aside. I'm going to ignore these little yeast until they start to show me that they're active and working. What I will be looking for I will be looking for a lot of really big, thick bubbles right on the surface of this sludge. That will let me know my yeast are awake, they've broken dormancy, they're eating the sugar, and they're ready to be added to the flour and turned into bread. Well, it's been about 20 minutes, and my yeasty beasties are awake, and they're working like crazy. And the way how I know is you can see that it looks like I have a lot more slurry. When I smell it, it smells a little bit like bread already. It's also super frothy and kind of bubbly here on the surface. So those are all the signs that we're looking for to tell us that our yeast have broken dormancy. They're awake and they are ready for us to use to bake bread. So in a bowl, I have be putting in the cup and a quarter of flour that I will be using today. The next thing that I'll be doing is I will be adding my yeast And at this point, I want to give a good stir. I want to get my yeast completely mixed here in with the flour before I start to add more water. The reason why I want to do that is because I don't want to add too much water. We want to add the just right amount of water to the flour to make everything come together so that we can work with it, because we're going to be putting it on a cutting board and starting to knead it. So take that extra step, mix your yeasty, watery slurry in with your flour, and then start adding some more water. When you do add water, make sure that that water is pretty warm. If it's the warm water from your tap that you use to wake up your yeast, that will actually be a good thing, because we want to make sure our yeast keep working, and they're going to want a nice warm environment in order to keep working. So I added my water in small increments. I started to mix it together, and it's just starting to come together as a cohesive whole. I don't want this to get too wet, too mushy. Otherwise, it's going to be really, really hard for me to knead, for me to work with. So I'm starting to bring it together into a ball, here in the bowl. The next step that I'm going to need to do is I'm going to need to start to knead this. What I like to do is I like to get a little bit of flour on my cutting board. I also like to get a little bit of flour on my own hands before I start to knead. This way, it'll make my kneading process a lot easier. So again, scraping the sides of the bowl, trying to get all of the little bits and pieces together, because we want to make sure that when we're looking at our data sheet that we all have used the same amount of flour, the same techniques when we're making our bread, so that we can start to make some conclusions on the different types of flours and how those flours affected the resulting bread. So I turned my dough out onto my cutting board. And what I really like about using a cutting board is, first of all, I can make sure this cutting board is clean, and then when I'm all done, it's a lot easier than trying to clean my counter, or in this case, my desk in my office where I work. So, if you have never kneaded bread before, the technique is going to be to use the heel of our hand to push the dough away, and then we're going to reach down and with our fingertips fold that dough back in on itself. When we are kneading the bread, what we are doing is we are aligning the aligning the gluten in our bread, aligning all of those proteins, starting to make them come together. And so I push in, I pull back, I push in, I pull back. Notice how I rotate it, and I keep the bread in this relatively circular form. Now, I added just a little bit too much water when I was initially bringing things together. So I'm going to take another scoopful of flour, put it on my hands, put it on the cutting board. I want to make sure I do it in small increments. I don't want to affect the size of my dough. I'm going to keep doing this for several minutes, potentially 5 minutes, maybe 7. I don't want to go to a full 10 minutes. Sometimes if you over-knead your dough, you can make your dough too chewy. I've done that before, and it just becomes, it becomes like bread gum, which sounds like it should be delicious, but really it's kind of gross. Now, one of the things that I'm noticing as I'm kneading and talking to you here, aligning all of those gluten proteins, is my bread is really starting to come together. It's starting to make that dough ball that we have become familiar with. A couple of measurements that you're going to take initially before you let your bread rise is you're going to press your finger in and see if that dough bounces back. You're going to press your finger in and see if any of the dough stays stuck to your finger. You want to clean your hands before you do this test for elasticity and stickiness. once you have taken those measurements, just knead it a couple more times. Get that finger impression out of your dough. Try to get it into a nice, perfectly round shape. You may want to use a clean bowl. I'm lazy. I hate to do dishes. So I'm going to go ahead and just spray the bowl that I was using to mix up the dough and water. I don't have a whole lot of bits stuck to the edge. I spray it with some spray oil. This is going to keep my dough from sticking to the sides of my bowl. The other thing it's going to do is it's going to help keep my bread soft when I bake it, so it's not going to come out with that really hard, crunchy crust. This is going to come out with a little bit of a softer crust. I'm going to cover it with some plastic wrap. I've got my ruler to take my measurement on how wide, what the diameter of my bread dough ball is here. And now I'm going to set it somewhere where I can essentially forget it and ignore it for about an hour. If your house is a little bit cooler, you may need to wait 2 or even hopefully not up to 3 hours. I hope your bread will rise in about 1 to 2 hours. But if we have a cooler house, or it's by an air conditioning vent, or a cold, drafty window, it might take a little bit longer. What we will be looking for is we are going to be looking for this bread dough to double in size. That means I'm going to expect it to be about this wide in this bowl, and just barely starting to press up against the top, starting to raise the plastic wrap. So, while I forget about this, what will be happening? The yeast will be consuming the sugars. The yeast will be consuming the carbohydrates and maybe even a little bit of the protein in the flour. When the yeast consumes the sugars, it will be doing aerobic cellular respiration. It will be breaking the sugars and making ATP energy. The byproduct of that will be carbon dioxide. Now we'll talk more about aerobic cellular respiration later this semester. But for right now, what we want is we want that carbon dioxide. The carbon dioxide is going to need to escape. So the carbon dioxide bubbles will build and build and build. That's what's going to force our dough ball to start to rise. When those carbon dioxide bubbles form, and that carbon dioxide is trying to escape, that's going to stretch those gluten proteins. Essentially, it is the carbon dioxide bubbles pushing and stretching the gluten protein that's going to make our bread so fluffy. Now, if you're like me, the smell of rising bread is going to make you hungry. So while you're waiting, you may want to get yourself a snack. So my bread has definitely risen and doubled in size. If we look really closely here, we can start to see a bunch of those little bubbles. Those bubbles mean that my bread is going to be light and fluffy. So what I'm going to do is put my cookie sheet on top of my bowl, flip it upside down, give it a little bit of a tap, and then I will be sending this bread down to the oven to go get baked. I'm going to bake it for about 20 minutes, but depending on our ovens and the variability, it might take up to half an hour. So keep an eye on it. And when your bread starts to turn golden brown all the way around the top, that's when you know it's ready. So here we have it, my finished bread. It unfortunately stuck a little bit to the pan. That happens sometimes, especially when you're trying out a new type of flour and a new set of methods. But here is the big reveal. When I crack it open, look at all of those delicious, fluffy little bubbles that have been left behind. So, without further ado, I'm gonna start eating this because it smells fantastic. I look forward to reading your data on the shared Excel document, seeing how your bread turns out. If you have any troubles, if you want to email me at any point, let me know. And also, I wanted to open up the idea that if you wanted to do this experiment more than once, you're welcome to do that, but we're only going to provide enough flour to do this experiment once. So hopefully bread making works well for you and you enjoy eating your bread. Email me when you get any questions.